Prices on what you need most will never change. Get 2 liters Right Brand sunflower oil, only $42.99, and 3 kilos Polana macaroni, just $59.99. Only at ShopRite. One stop, one safer shop.
Today we're starting with a totally new topic, and this is the topic of logarithms. Now, you already did this last year, so it is not totally new, but we are going to do some extra work here, and we eventually want to draw exponential graphs also from logarithms. Now, our first lesson is a very basic lesson. When I write something like this, 2 to the power of 3 is 8. This is index notation. What we want to do now is to change index notation to logarithmic notation. So what we do is to say that log base 2 of 8 is equal to 3. So this is a very basic example, but please write it down and remember this. Whenever you are stuck and you don't know how to answer a question, think back about this. 2 to the power of 3 is 8. Changes now in logarithmic notation to log base 2 of 8, which is equal to 3. So we're going to work now in our textbook. We're using this one, Cambridge, book 3, and we're starting on page 51, exercise 11. And this whole first exercise is just to familiarize you with the conversion. So what we're doing is 2 to the power of 3 is 8. And I want to change this now to log base 2 of 8 is equal to 3. Just familiarize you now with this notation. Right. So there's the first one. It will be log base 2 of 128 is equal to 7. The next one, log base 3 of 1 over 729 is equal to negative 6. Log base 27 of 1 over 9 is equal to negative 2/3. This one, log base 2 of 1.516 is equal to 0.6. The next one, log base 5 of x is equal to square root 2. Log, look at this one. This is the base, log q of p is equal to r. The answer is the index. This one you can do either way. Log base a of x to the power of y is equal to b. When we move now to exercise 2, we're changing now logs to indices. So this is now the other way around, logs to indices. So this means this one will be 3 to the power of 3, which is equal to 27. This one, 5, that's the base, to the power of negative 2 is 1 over 25. This one, 10 to the power of 1 is 10. 10 to the power of negative 3 is 0.001. Square root 2 to the power of 6 is 8. b to the power of a is equal to c. And this one, a to the power of d is equal to b to the power of c. Those conversions. Right. Now, the next exercise says, find the value of the expressions given below without using a calculator. In the exams, you might use calculators, but this is now just to familiarize us. I'm going to do exactly the same thing, writing it from logs to indices. So, do you remember? 2 to the power of 3 is 8. So, log base 2 of 8 is 3. So, I move there. So, this one will be 5 to the power of what is now 25. And we know that that is 2. 5 to the power of 2. These ones are easy. You should be familiar with them. But otherwise, we can also calculate them. And what we do then is to write this one to the same base. And that's how I get that 2 there. So this one is then 3 to the power of what is equal to 3. And it will be a 1. The bases are the same, you can see. The next one, 3 to the power of negative 3 is equal to 3 to the power of negative 3. So this one's answer is then actually negative 3. Can you see it is that value there that we get there. This one, number D, 25 to the power of what is giving you 5. And again, we have to change them to the same base. We have to change them to the same base. So 25 is 5 to the power of 2. So the answer for this one will then be a half. 25, so 25 to the power of a half will give me 5. Number E, 4 to the power of what is giving you 1 over 16. 1 over 16 is 4 to the power of negative 2. Because it's there, it's this rule. The negative index is the positive reciprocal. This is what we use there. So the answer is negative 2 there. Number F, 3 to the power of what is equal to a third. Again, a third is 3 to the power of negative 1. That's why your answer here will be negative 1. And then the last one, number G, a third to the power of what is equal to 3. So I need to change them to the same base. So this one is then 3 to the power of negative 1. 3 to the power of negative 1. Right, number 4 on the next page, solve x for each of the equations given below. Again, I'm rewriting it now in index notation. So this is then 4 to the power of x is equal to a half. Still changing it, still working with this. 2 to the power of 3 is 8. Log base 2 of 8 is 3. So the question is now 4 to the power of what will give me a half, an answer of a half. Now, what we do there is we change them to the same base, which means this one is going to be 2 to the power of 2x is equal to 2 to the power of negative 1. And then we solve the bases are the same, so we solve the top. So you're going to say 2x is equal to negative 1, which makes x equal to negative a half. So we can calculate them in this same way. We can do the calculations then there of that one. The next one, 10 to the power of negative 2. 10 to the power of negative 2 is what? And this one is easy. It is 1 over 100. right? So let's try to do them on this side, perhaps be better. Number B is then 10 to the power of negative 2 is x, and this is 1 over 100. Number C, 2 to the power of what is equal to, now 1 over 32, I can rewrite it as 2 to the power of negative 5. Now, how will I know that? If you don't know it, we go back to our grade 8 method where we said 32, finding that highest common factor where you divided it into prime factors. So you divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. So that's how I know that it is 2 to the power of 5. So if you don't know, you go back to this method. And because it is there, that's why it's equal to the negative reciprocal. Now your two bases are the same here, so the answer of x is equal to negative 5. Negative 5. Number D, a third to the power of negative 3 is equal to what? A third to the power of negative 3, so it will be the reciprocal, and this one's answer will be 27. 27. Right, number E, let's try this one on this side. So x to the power of 3 over 2 is equal to 10 square root 10. And 10 square root 10, this is to the power of half. Remember, there's a little 2 there, and this is a 1, so it is 1.5. So x to the power of 3 over 2 is equal to 10 to the power of 3 over 2, which makes x in this case 10. X is equal to 10. Number G. So a quarter to the power of 2.5 is equal to x. Now that one you can just get on the calculator. So 0.25 to the power of 2.5 is equal to 1 over 32. So this one is 1 over 32. Number H. Number H is then x to the power of negative 4 over 5 is equal to 1 over 16. This one is 4 over 5. So I will change 1 over 16 to be 2 to the power of negative 4. 2 to the power of negative 4. Or 4 to the power of negative 2. You can also use that. So now this one is a little bit more difficult. So what I want is x to the power of 1. So we multiply here with negative 5 over 4, because then it will cancel out and you have x to the power of 1. But what we do on the one side, we must do on the other side. So if you power here to negative 5 over 4, then the 4's will cancel out, and it will then be 2 to the power of 5, which is 32. That's that one's answer. Right. Now, what we do with number 5 is we get values. We get, right, and we're looking at the last three, number 5, 6, and 7. Now, here you'll have to get values for each one. We have to find values for each one. So I can say, this is now number 5. So I can say that this is 2 to the power of, now look at that one, that is 2 to the power of a third. So this one's answer is a third. And that one is 3 to the power of a half, because that is the square root of 3 is 3 to the power of a half. So it's a third plus a half, which gives me then 5 out of 6. 5 out of 6. The next one, number 6. Again, I have to get values there. So 6 to the power of 2 is 36. 2 to the power of 5 is 32. And 4 to the power of 3 is 8. 4 to the power of, sorry, this is not 81. So this one will then be, to calculate it, you will say 2 to the power of 2, that's the base, is equal to 2 to the power of 3. You can also press these answers on your calculator, then we can also get an answer there. So number 6 is now 6 to the power of what is 36, and that's how I get the value of 2. The next one, 2 to the power of what is 32, and that is 5. Again, if you don't know, you go through that, writing it as a product of its prime factors. And then let's look at the last one. That one is now 4 to the power of what is equal to 8. So I need to change them now here to the same base. So this is 2 to the power of 2x, and this is 2 to the power of 3. Remember, if you don't know, this is what you're doing. You divide by the 2 all the time. That's how I get the 3. And now, because my bases are the same, I solve the indices. So x is equal to 1.5. X is equal to 1.5. And now if you add it, 2 plus 5 plus 1.5, the answer is 8.5. 8.5. Number 7. Again, I have to change all of them to the same base. So the first one is 3 to the power of what is equal to 1 over 81. 1 over 81 is the same as 3 to the power of negative 4. Again, you use this method to find that value. 3 divides into 27, 3, 9, 3, 3, 3, 1. This is where I get the 4. Because it's the denominator, it's negative 4. So x is equal to negative 4. That is the first one. The second one there will then be 9 to the power of what is 27. 9 to the power of what is 27. So changing it to the same base, 3 to the power of 2x. 9 is 3 to the power of 2x. 27 is 3 to the power of 3. So your bases are the same. That's why you can solve the indices. So 2x is equal to 3, which makes x equal to 1.5. So it's negative 4 plus 1.5 here. And then the last one, let's just try that one as well. That one is then 4 to the power of what is equal to 1 over 32. Changing them to the same base. So the base is 2, 2x. This one is 2 to the power of negative 5. We already had that one there. Because it's below, it's the reciprocal, the change of sign. So now we're going to solve this part here. 2x is equal to negative 5, which makes x equal to negative 2.5. So plus negative 2.5, and this one's answer is then 0. The answer there is 0. Right, let's continue with exercise 12. Exercise 12. And it's, again, they say without calculator, so we just have to find it. So the first one looks like this, log base 10 of 10. Changing it to index notation is 10 to the power of what is 10 to the power of 1. And you can easily see that this one's answer is 1. Number B, this is A. B, log 5 of 5. Now it's the same thing. 5 to the power of what is 5 to the power of 1, and x is then equal to 1. Is equal to 1. So that means if we have the same number, it will always be 1. It will always be 1. So number C's answer is 1, and number D's answer is also 1. Question 2 there. Without using a calculator, find the value. Now this one looks like this, like log base 10 of 10 to the power of 2. Again, I'm rewriting it in index notation. So 10 to the power of what is 10 to the power of 2. My bases are the same. So there's the solution, and the answer is 2. Let's look at another one there. Log 5 of 5 to the power of 3. Rewriting it in index notation. So 5 to the power of what is 5 to the power of 3. And my answer will be 3. The answer will be 3. So number C is then 6, and number D is -3. So I can just use that power there. Question 3. Now look at this one. Log base 2 of 0. This is invalid because that should be, no, we can write this one as 2 to the power of x is equal to 0. Yes, and that is invalid. That cannot work. Look at number 4. 10 to the power of what is equal to 1. And we've learned that anything to the power of 0 is 1. So x is 0 in this case. And the last one, log 1 of 4. This is also invalid. We can't get those values. The next exercise is now exercise 13. Today's lesson is just an introduction to familiarize you with all this way of writing. So it says log 3 of 9. So we write it in index notation. 3 to the power of what is 9. Change it to the same base, 3 to the power of 2. So the answer is x is equal to 2. Number 2, log base 2 of 1 over 8. Write it in index notation. 2 to the power of what is 1 over 8. Now I need to change it to the same base. This one is 2 to the power of -3. So your answer is -3, the answer there. Number 3, log 7 of 7. We looked at these ones just now. If it's the same one there, 7 to the power of what is 7 to the power of 1. So the answer is 1. Number 4. So that one will be 10 to the power of what is equal to 1 million. If I change a million to the same base, then it is 10 to the power of 6. So x is going to be 6. X is going to be 6. Number 5. 5 to the power of what is 0. That one is invalid. It has no meaning, so we can just say invalid. Question 6. 9 to the power of what is 1 over 81. Changing it to the same base. So this one is 3 to the power of -4. And this one is 3 to the power of positive 2x. So the bases are the same, and I can then say that 2x is equal to -4, which makes x equal to -2. X is equal to -2. Number 7. 3, I've mixed the two, so this is now number 7. 9 to the power of what is equal to 1 over 81. If I change this one to the same base, it is then, we can actually change both of them, but we can work here with 9 to the power of negative 2. So x is then negative 2. The value of x is negative 2. Number 8, 4 to the power of what is equal to 1? And that is anything to the power of 0. Number 9, 3 to the power of what is equal to 1? That one's answer is also 0. Number 10, 12 of 12, so we know that is the same now by now. 11, 2 to the power of what is equal to 2 to the power of 43. So it's 43, my bases are the same. And number 12, 1 to the power of what is 6. And this is again invalid. This is again invalid then there. Right, then we look at exercise 14. Still just an introduction there. Solve A. So we can say that A to the power of 4 is equal to 81. So the question is now, what will give us that answer there? Again, you can go through that method of dividing by 3, 81 there, 27, 9, 3, 3. So this is then, A is equal to 3. A is equal to 3. Or what you can also do is to change this one then to 3 to the power of 4. And now because your indices are the same, we can find the basis. Number B, A to the power of 2 is equal to a quarter. I change this one to the same base, so it becomes 2 to the power of negative 2. 2 to the power of negative 2. Number C, A to the power of negative 2 is equal to a quarter. A quarter is the same as 2 to the power of negative 2. So now your indices are the same, so the base is equal to 2. The base is equal to 2. Number D, A to the power of negative 3 is equal to 125. So I can change 125 to 5 to the power of 3. Again, you'll go through this method if you don't know what it is. But now this one is negative and that one is positive, so I still can compare that one. What we can do here is to reason you want A to the power of 1. So I'm going to multiply here with negative 1/3, because then it will cancel out and I have that answer. But what you do on the one side, you will do on the other side. So I will also change it there. 3's will cancel out, and it is then 5 to the power of negative 1. 5 to the power of negative 1. And the last exercise now there is number 2. 2 to the power of 6 is 64. 8 to the power of 2 is 64. 4 to the power of 3 is 64. Just rewriting it from logs to indices. And the last one, 10 to the power of negative 3, is equal to 1/1000. So grade 12s, make sure that you understand this introduction, converting then from logs to indices and indices to logs.